Next we move over to the bitwise operators. Bitwise operators, very important to keep in mind that they operate only on integer operands. So, integers is the data types integer, character, short, long, int, etc. Now, I said integer operators and I am saying character here. Characters also can be represented using their ASCII values. So, that is why that also has been mentioned here as an integer operand. So, the operators that are there in bitwise is left shift, right shift, bitwise XOR, ones complement, bitwise and bitwise OR. This XOR and OR are similar to the binary arithmetic, where we have two zeros, it gives a 0 and a 1. In case of OR, it returns a 1. In case of AND, both the operands have to be 1 if the final result is 1. So, I will just give you an example of how this bitwise shifting is done. The rest of the operations follow the similar order. So, here we have a number 8 and we all know its binary representation is 1000. So, when bitwise execution is done, this is how it is implemented in the computer's arithmetic. First we have 2 raised to all the powers up to 16 because it is 16-bit integer, and we have from 0 to 15 represented as double digit values. And here we have written the binary representation of the number 8, 1000. So, it comes as 2 to the power 3 is 8. So, that is why we put a 1 in the third position. Now, the operation that is to be done is right shifting by 2 bits, that is shown as x greater than, which is a symbol for a right shift, is equal to 2, which indicates that the number x has to be right shifted by 2. So, x is 8 and that has to be right shifted by 2. So, if you will see the next step, the bit 1 moves from the third position to the first position because it is a right shift. So, it shifts right by 2 bits. So, if you will measure up its value, it is 2 to the power 1, which is equal to 2. So, 8 when it is right shifted by 2 bits, the final result to the programmer is 2. Now, this is the formula for performing a shift operation. Y is equal to n divided by 2 to the power s, where n is the number and s is the number of bits it has to be shifted. So, if you apply the same formula to this particular example, here n is 8 and s is 2. So, 8 divided by 2 square, which is equal to 8 divided by 4, the final result is the same 2. So, these either you can evaluate and see whether your answer is correct using the formula or using this shift operation itself.